the vector equation of a line. Okay, before I tell you about the vector equation of a line, I should take you back to the equation of a line, which is like y is equal to mx plus c. You remember that this m over here, this basically tells us the uh, about the gradient of a line. It tells us that how steep is the line. Okay, and the second thing is this c. This tells us about the location of the line, that where is it going to pass through the y-axis. Okay, so m tells us about the gradient, the slope. Okay, and c tells us about its y-intercept. Okay, and then suppose you have an equation y is equal to 2x plus 3. Now this generally tells us about the relationship between the x coordinates and the y coordinates. Though this gradient is telling us about its steepness, this is telling us about its y-intercept. But on the whole, this equation of the line tells us about the properties of the coordinates of the points on this line. Okay, and this line is also, since it is in 2D, so you have this x and y in it. Okay, these x and y, these are the variables on this line, because if you look at this line, for example, if the line is like this, so um, if you move on this line, like if there is a point A, there is a point B, there is a point C, so you know that the gradient of AB is same as the gradient of this BC or the gradient of this AC. That is the feature of this gradient, this 2, that the steepness is going to be 2. Okay, and then it is when it is passing through the let's say there is the y-axis over here, so the this is 3 over here. You have another line with the same gradient, and if it has a y-intercept of 5, like there is another line y is equal to 2x plus 5. So this 3 and 5 will help you to determine that, like if this is the line L1, this is the line L2, so you will be able to determine that which of these lines is has the equation, this one or this one. Okay, so now we have to go into the 3D. Since we are dealing with the vectors in 3D, and we have to see that how to write the vector equation of a line. So once you write the vector equation of a line, so again the purpose is the same, that you must be able to uh, determine that in which direction this vector is going, and you should have a point like this to tell you about the location of that vector whose equation we are writing. Okay, and then most importantly, you will be able to see the relationship between the x, y, and the z coordinates. Now the vector equation of a line is written in the form r is equal to a plus lambda b. Okay, this is r is equal to a plus lambda b. Now this r is going to be like if there is a line like this. Okay, so there is a point, let's say P, there is a point A, there is a point uh, B. Like if I take a point P over here, for instance. Okay, so like you must be, for example, if this point A is this line over here, y is equal to 2x plus 3. So if this x coordinate over here is -1, and you know that the y coordinate is going to be 1 over here. Okay, this b, if this has an x coordinate of 1, so you know that the y coordinate is going to be 5. But this point P is a general point. This is going to be x comma y on it. Okay, so this point P over here is going to be a point, let's say, I'm just going to write them in matrix form. This is x, y, z. Okay, So this R is a general point. This is representing X, Y, Z. This can also be written as X, Y, Z equal to, and then this A is going to serve the purpose of the C, okay? This A is the position vector of a point on our vector. Like you have this C over here, that is a point on the line, okay? And this is mainly passing through the y-axis. But this point can be anywhere on this vector, okay? This can be the point A, this can be the point B, just to um, be very clear about the position of the line, okay? So this A has to be, this is the position vector of a point on the line, okay? Then this lambda over here. This lambda is going to do the same thing as this m does here, okay? This B is going to be the direction vector of or parallel to the line. If you are noting it down why I'm writing it here, then you will be able to remember this, okay? So we have this R is going to be X, Y, Z, and suppose this A is a point, let's say this is 2, 3, 1, and then plus lambda into, let's say this is 3 minus 2, 4. So you have a line like this, okay? So um, you must be wondering that what the hell is this lambda doing here, okay? I'll tell you in a minute. So R is in general a point on our line. This A is, for example, this can be your A, which is 2, 3, 1. And this lambda, this D is the direction in which the line is going, okay? This can be a direction both ways, okay? So the direction vector of the line, okay? And this lambda is basically, this is used to determine the coordinates of different points on this line. For example, if you put lambda as 0, what will happen? You will be left with 2, 3, 1. So this point is already here on um, this line, okay? If you put lambda as 1, for example, you put lambda equal to 1, okay? So this x, y, z will be equal to, this is 2 plus 3, it is 5, 3 minus 2 is 1, 1 plus 2 is 5. So this can be the coordinates of a point, like this b can be a point 5, 1, 5 over here, okay? So if you put different values of lambda, you will be getting different uh, points, coordinates on this line. Okay, so using all this information, you can learn that how to write the equation, the vector equation of a line. Okay, so when you have to write the vector equation of a line, you will be starting with R is equal to A plus lambda B. First of all, the very typical situation when you have you have been given 2 points on the line. Like for example, you have been given that there is a point OA, which is 3, 2, 1, and there is a point OB, which is 5, 4, 6. Okay, so you have to write down the vector equation of a line containing these 2 points. Okay, now this A, you can keep this OA as your A, or you can keep your OB as your A. Both can, like, be fitted on the place of this A over here. Now this B is going to be the direction vector. So you can either find AB or you can find BA for this, okay? So that is OB minus OA. So this is going to be 5 minus 3 is 2, 4 minus 2 is 2, 6 minus 1 is 5, okay? So the vector equation of the line which is containing these 2 points A and B, or passing through these 2 points A and B, is going to be R is equal to 3, 2, 1 plus, you can use mu as well, mu A, B, C, K, L, whatever you want to use this. Okay, so this is going to be 2, 2, 5. This can also be written as x, y, z, that is equal to 3, 2, 1 plus 2, 2, 5. Okay. So that is how you write the vector equation of a line. This is called the vector equation of a line in Cartesian form. Okay. We have the polar form, I mean the parametric form as well here. What is the parametric form? That is quite a simple thing. You see that I can write the same as x, y, z, that is equal to, oh sorry, there was a mu over here. I just missed that. No one told me. Um, just a minute. Um, so this is plus mu, okay? So now this can be written as 3 plus 2 mu, 2 plus 2 mu, and 1 plus 5 mu. This is still the, I mean, the Cartesian equation, but if you split them as, if you write it as your x is equal to 3 plus 2 mu, your y is equal to 2 plus 2 mu, and your z is equal to 1 plus 5 mu. So these are the parametric equations of the vector equation of the line containing these 2 points A and B. Any question, Bachu? Hmm? Now, you can also be asked, like, as if you remember that when you were dealing with the coordinate geometry, that you were given 2 points, like you were given that there's a point 3, 4, and there is a point 2, 5. Find the equation of a line. So you were finding first m, and then you were either using y is equal to mx plus c, or you were using the method y minus y1, that is equal to m into x minus x1. So that is the most typical case when you're given 2 points and then you have to write the equation of a line. So here, the first case is that you, as I did here, that you were given 2 points uh, contained by the line, and then you have written down the vector equation of a line. And then there are cases like, suppose you have to write the equation of a line. You're given that there is a line passing through 3, 4, and this is a gradient, let's say half. So you don't need to calculate the gradient. So similarly, when you're writing the vector equation of a line, you can be given that, okay, there is a line there's a line L which contains a point A, which is, let's say, 1 to 5, and is parallel to the line R is equal to 3, 4, 6 plus lambda into minus 1 to 7. Okay. So we have to write down the equation of a line which is passing through the point A and is parallel to this line. So when two lines are parallel, you know that their direction vectors are going to be same. They are in the same direction. So the required equation would be R is equal to 1 to 5 plus K times minus 1 to 7. That is the equation that we could write. Okay. So and then if suppose if you write its parametric equation, so that would be x equal to 1 minus k, and y is equal to 2 plus 2k, and z is equal to 5 plus 7k. Okay, guys, from here, we'll be moving on to the, the book, okay, where you will be practicing the questions from the book, okay. So I have the book ready for you. Here is the book. So you have to start from, this is exercise 9D, okay? So please start your work. So in this first question, you say we have to write down the equation of a line through the point A, and it is parallel to this vector B. So there's no working required. You can simply write for this R is equal to 0 minus 1, 5. And then you can write plus lambda into 2, 6 minus 1. So that is the equation of a line that contains a point A and is parallel to this, okay? Then it says in the second question, now look at this B part. This is really interesting. The B part would be R is equal to, simply you can say this is mu times 7 minus 1 minus k. Okay, since it is passing through the origin, this is exactly the way we write the line, the equation of line y is equal to 2x or y equal to x. You see, for sure these lines, they are passing through the origin, so the y-intercept is 0. So there's no need to write a plus 0 over here. Okay, then it says write each of your answers to the question number 1 in parametric form. So the parametric form for the first one would be this for the a part, this can be x equal to 2 lambda, and then you have y equal to minus 1 plus 6 lambda, and then you have z equal to 5 minus lambda. That is how you will be doing the writing them in the parametric form. Next, it says show that the line through the points there is parallel to this line. Okay, so I think you should just start trying them, and just keep on noting down your problems, and then I'll help you out. Okay. Okay, third question. It says show that the line through the points this and this is parallel to the line this. Okay, now suppose here are the points. This point A is uh, 9 to minus 5, and here is the point B, which is 1 7 1. Okay, so there is another line whose equation is R is equal to lambda into um, 16 minus 10 and minus 12. Okay, so we have to show that these two lines are basically parallel to each other. So how can you do that? If you just find the direction vector of this line AB. So this AB is going to be OB minus OA, which is going to be 171 minus this 9 to minus 5. So this is minus 8, 5, and 6. Okay. Now its direction vector is this, and if you see that the direction vector is here, if you see that you can simplify this, or if you write the direction ratios here, okay, this is going to be 8 minus 5 minus 6, or you can also write it as minus 8, 5, and 6. So this one has the same minus 8 ratio 5 ratio 6. So you see that the same direction ratios or the same direction vectors, if you like, just take a minus 2 common from here. So that is how you can prove that these two lines, they are parallel to each other. Okay. Okay, the fifth question. It says find the parametric equation, the line through the points this and this. Okay, so first of all, we have to write the Cartesian equation, and then we can write the parametric equations. Okay, so you see, there sometimes examiner don't even give a single mark for writing the equation of a line, vector equation of a line, because this does not require any working even. So you see how quickly I'll be writing this equation of the line. This is 0 4 minus 2, and then plus lambda into, and I say this is 1 minus 0 is 1, 1 minus 4 is minus 3, and 6 minus minus 2 is 8. So that is the vector equation in Cartesian form for the line passing through A and B. Okay, now the same line can also be written as this is x equal to lambda, and then you have y equal to 4 minus 3 lambda, and z is equal to minus 2 plus 8 lambda. Achha. Once you have learned how to write down the equation of a line and how to write the parametric equations of a line, then you see that the problems coming ahead, that where you will be learning how to find the point of intersection of two vectors, the angle between two vectors, the blah blah vector passing through blah. So in all these situations, you will actually be finding that particular value of lambda. So one of the examples is here. It says, find the coordinates, the point where the line crosses the OXY plane. Do you remember in your coordinate geometry, suppose you have a line which is 2x plus 3y that is equal to 6. And then you have to find the coordinates of point where the line passes through the x-axis. So you know when the line passes through the x-axis, for example, if this is your line here, so if it passes through the x-axis, you know that this is going to be something x comma 0. If it passes through the y-axis, this is going to be a point something 0 comma y. Okay, so for this particular point, you will put y equal to 0, and you will get that 2x equal to 6 and x equal to 3. So this point will be 3 comma 0. Similarly, when you have um, uh, the situation where you have the 3D like situation. So this is your x, this is your y here, and this is your z. Now, if a line is purely passing through the, let's say, z-axis, so that means that their x and y coordinates would be 0. Like any point over here would be something like 0 comma 0 comma, let's say this is 5 over here. Okay, a point over here will be having the x and the z coordinate 0, so this can be 0 comma 2 comma 0. Any point over here would have the y and z coordinates. Let's say this is going to be 7 comma 0 comma 0. Okay, but if you look at this, this is your yz planes. So if you take any point on this YZ plane, you must be sure that the X coordinate should be 0 onto that point. Like if you take a point over here, for example, so this point can be 0 comma 2 comma 5. Okay, this point over here is 0 comma 2 comma 5. If you take a point here on the YX plane here, this is your YX plane. Okay, so for example, you're taking um, this point over here, okay, on the XY plane. So this can be 7 comma 2 comma 0. Okay, because there is no height. This is just on the floor of your room. Okay, this is a point on the wall. Okay, if something is on the XZ plane, so you can well imagine that the y coordinate would be 0 there. So it says the OXY plane, okay? The OXY plane. So what is going to be 0 onto the OXY plane? Which coordinate would be 0 if the line is passing through the OXY plane? Yes? Dacho, asking from you. Hello. You should be clear that if a point, if you take any point, like just imagine that this is your room over here, okay, and you are sitting in your room. Suppose instead of origin, you take the origin over here, okay. This is your z, okay. This one is your x, and this one is going your y like this, okay. So if you see that there is something lying on the floor, so that means your floor is going to be XY plane. So there's no height uh, to be considered to tell the position of that point. Now, suppose there is a spider moving on your roof, okay, on your ceiling, exactly. So the ceiling is basically uh, again, the ceiling is going to be your XY plane. And look at this. This would be your ceiling like this. Okay, so this is your x direction, and this one is your y direction. Okay, so this is the xy plane, but this is already, since we're determining the height from here, from this origin, so this will have a z coordinate. But anything which is lying on the floor, that means this is going to be having the 0 z coordinate. Anything which is on this wall over here, that is going to be having the 0x coordinate. Okay, anything which is on this wall over here, which will have the 0y coordinate. Okay, so this way, please just note it down that on the xy plane, z is 0. On the yz plane, your x is 0. And on the xz plane, you have the y equal to 0. Now, when you're dealing with the 2D, you have the x-axis and the y-axis. When you're dealing with the 3D, uh, um, then you have the planes instead of the x's, okay? The xy plane, the yz plane, and the xz plane.